Many headwinds make implementing and delivering value around AI intimidating. The Dell AI Factory with NVIDIA turbocharges your AI adoption with the industry's first end-to-end enterprise AI solution that simplifies development and deployment. It starts with your data. Whether it's creating digital assistants, giving developers coding support, or providing teams with the tools they need for success, you can drive growth and improve productivity while ensuring security. With this comprehensive AI solution, you get trusted AI infrastructure with integrated AI software, models, and workflows, all in one place. No matter where you are on your AI journey, Dell Professional Services and NVIDIA can help you with leading capabilities tailored to your objectives, so you can tap into our simplified, tailored, and trusted framework for AI success. Get up and running up to 7 times faster than doing it by yourself with the Dell AI Factory with NVIDIA, and start transforming innovation into value.
Hey Copilot, find the sales stats my manager sent last week.
So here's the thing. All the greatness in the world, every feat, every breakthrough, every game-changing, paradigm-shifting accomplishment you admire out there, didn't come from out there. See, greatness, true greatness, your greatness, it can be easy to lose sight of. But it's here, inside all of us, inside you. And greatness, that can always grow greater. All it needs is ignition. So let's hit that switch, push the throttle, kick that door wide open. After all, we know a thing or two about what's inside, how to amplify it, how to multiply it, accelerate it. So you're not just leaning into the future, you're launching into it. With more ingenuity inside, more creativity inside, more security, innovation, intelligence. Because that greatness inside you, that is your superpower. Helping you unleash it? That's ours.
For more than 2 decades, Carahsoft has been the trusted partner to the public sector, connecting agencies and organizations with the technology they need to drive change. As the master government aggregator, Carahsoft bridges the gap between thousands of leading technology vendors, resellers, and system integrators, delivering tailored IT solutions for federal, state, and local governments, as well as education and healthcare organizations. From telework and online learning to collaboration tools and scalable communication systems, Carahsoft's portfolio empowers agencies to operate efficiently, securely, and innovatively. The stakes are high. National security, public health, education, and government operations depend on technology that works flawlessly, securely, and at scale. That's where Carahsoft comes in. Through its robust technology portfolio and expansive contract vehicles, Carahsoft makes it easier for agencies to find the right solutions to meet their missions. The missions are clear: enable the public sector to solve today's challenges and prepare for tomorrow's. Carahsoft doesn't just connect technology with the public sector. Carahsoft drives innovation, empowers communities, and shapes the future.
Listen up, all eyes on me. I'll show you who you wanna be. Hey, yeah, yeah, hey. Look at that, you won't believe it's all you want, it's all you need. Hey, yeah, yeah, hey. Oh wow, wow, wow. It's going down, down. Oh wow, wow, wow. Talk of the town. You ain't seen nothing. I'll show you something. Oh wow, wow, wow. You don't wanna miss this. Is it? Oh wow, wow, wow.
Please welcome VP Dell Technologies Federal, Suri Durvasula.
Good morning. Thank you all for being here. A lot of you know that I like to say funny things, and in my head I have a funny thing going on, which is this morning I was told I have a lot of stage riz. So help me validate that. Let me know. I'd like feedback. Look, as I was preparing for this moment, gave me a moment to think about my background. I've spent the majority of my career, both at Dell and prior to Dell, working in the public sector. I served as a public servant and then worked in government, or in the commercial world supporting government. And so for all of you that have supported or served in a public capacity, thank you very much for your service. It's a challenging role, and I just want to say thank you for all you did and all of your sacrifices that you continue to do. So thank you. Appreciate it. Today we're at an interesting time for public sector and our overall federal mission. We look at it and we go, technology is the major innovator, it's the enabler, yet it's a challenging thing for us to all enable in the federal space, given all the legacy and technical debt that we have to overcome. We have challenges coming around, whether it's related to cost, the cost of innovation, the speed at which innovation has to happen, and the challenges that are all, that we all face every day. Ultimately, we have to do it. The stakes are high. Our need to keep up with other countries and deliver the services that our citizens require is an all-time must. And in order for us to go do that, we have to figure out how to get value from what we're delivering, how to reduce our costs, gain efficiency, and modernize all at the same time, while ensuring that our data is all remaining in a secure and immutable posture. The challenge for us to do that is enormous, but the opportunity on the other end of it is even greater. As citizens, we all know that we want more from government. We want to see the outcomes. We want to see the enablement of AI to help with healthcare, citizen services, national security. Until we get that innovation to happen within government, we can't deliver that for our citizens ahead. And for us, we all demand that from government. And so it's upon us to go figure out how we're going to take AI and all these new technologies and deliver outcomes that are going to be meaningful to us as a population, but also to our country. So when I think about this and I see what's happening across Department of Energy, I don't believe there's a better sort of program that's been stood up that aligns to this value of driving scale, driving innovation, driving true outcomes that'll keep us, moving ahead and delivering scientific discovery, enabling our citizens to, become future state. And that's what the Department of Energy is doing, aligned with the Genesis mission and the program that's being put together. So with that, I would like to welcome Dr. Darío Gil, Undersecretary of Science at the Department of Energy, also the Genesis Mission Director, to the stage, and the Chairman, CEO, and Founder, Michael Dell. Thank you. So, Michael, I'll start with you. You've been spending a lot of time in DC. I've seen you quite a bit. Really would just, there's a lot of familiar faces here, a lot of our partner community, customers, the whole ecosystem here. Kind of would love your thoughts about, your time in DC recently.
Sure. Well, first of all, great to be back here and with so many familiar faces. We've had the privilege and honor of working with the United States government really since the start of the company. Back in the Reagan administration when I started the company, the government's been our largest customer from the beginning and continues to be. So we invest a lot of time understanding your mission, and the input that you give us kind of drives our innovation engine and influences what we're designing and the services that we deliver. So, our goal is to be embedded in your activities and support our American citizens at home and abroad with technology. And from, battlefield to national security to public health, transportation, disaster response, obviously research and accelerating scientific discovery, space exploration, energy security. We're proud and honored and think it's the most important mission that we have. And, we often thank you because your mission inspires our teams. And, it creates an incredible connection with the work that we do with our teams. And it's just an honor for us. So great to be with you all. Darío, thank you for being here. Looking forward to your comments and hearing your perspective. Thank you.
Thank you. And by the way, mission, my team is all mission focused. Many of us and all of us, I believe, in this room are all very mission focused. And I love that our company has really rallied behind that, including some of the marketing that you saw here. It's really amazing that we're, aligning to the message. So thank you all. Michael, I'll start with you. Just as you think about technology, from where you started the company to now, it's come to fruition. Technology is an enabler of everything today. Kind of where do you see it going, and where do you think government can really take advantage and accelerate, on the opportunity?
Well, I think this is definitely the most exciting time in technology until tomorrow, right? and Darío and I were talking about this earlier. The pace of acceleration and improvement and progress is not slowing down. And, I think the ideas and concepts are moving into production faster than ever. We're seeing, projects in the government move from pilot to production in a material way. Certainly, I think sometimes we forget the substrate of all this is data, right? And data is the fuel for AI, and there's an enormous amount of data at the edge, and we are very focused on how do we bring the compute and the AI to the edge where the data is being generated, and really, again, understanding the mission. And our kind of stock and trade as a company has been these open, interoperable stacks of solution technology, and we've learned a ton in the commercial and enterprise world about building the most advanced data centers and AI infrastructure, and doing that in a repeatable, validatable way to accelerate the progress in the national labs and in all parts of the government is incredibly important. And certainly all of this is amplifying human capability and judgment and accelerating progress, and that's kind of what we're all about.
Yeah. Darío, you've spent more than 2 decades driving innovation, most recently at IBM's Global Research Division. When you think of national science, the strategy, you're bringing a lot of thought process into government that we've never had. Kind of where do you think that we need to go, and how do we unlock that scale, especially when it is government? And obviously it's different under this new administration, but how do we really drive the value at scale?
Well, good morning, everybody, and Michael and Real, thank you for inviting me and being here with all of you. As Michael alluded, I think this is the most exciting and consequential time in technology and specifically in the world of computing than we've ever had. And what we're very excited about in the context of science is with the launch of the Genesis mission, which was launched the Monday of the week of Thanksgiving by the president, we are seeking to revolutionize how science and engineering are practiced in our nation, harnessing that computing revolution. So today, we spend $1 trillion a year as a nation doing research and development. And we believe that it is possible to double the productivity and impact of that $1 trillion a year within a decade by doing 2 fundamental things. The first thing is to build a platform to accelerate discovery. And this platform will be built on 3 pillars. It'll be built on all the decades of progress of semiconductors and high-performance computing, on AI supercomputing, and on quantum. And what we seek to do is to bring those 3 capabilities together and build on top of it an agentic AI framework designed to accelerate the scientific method. We seek to provide that capability at scale, first to all 40,000 scientists and engineers and technical staff across the 17 national laboratories of the United States, but also to diffuse it through all aspects of the federal government and of universities and industry. The second thing is we're not only going to give that platform and make it accessible to those scientists and engineers, we're very keen of implementing complex closed feedback systems, connecting that capability with the most exquisite scientific instruments that we've ever built and that we operate across the national laboratories. And that speaks to the edge component. It speaks about having these complex workflows that could be running in an automated fashion from hours to days to weeks to eventually months. So that's part 1, platform. And part 2 is we're going to demonstrate it on things that really matter to our fellow citizens. So we have launched 26 national challenges spanning energy, discovery science, and national security. We will be expanding that set with federal agencies ranging from NASA, NSF, NIH, and others. And the idea is to then motivate the best teams in the country to propose solutions to some of the most ambitious challenges that we face, spanning the grid, fusion energy, nuclear, healthcare, discovery science, et cetera. And those are the 2 hands of the Genesis mission. A platform build, problem solving on things that really matter. The problems inform the platform give capability to the problem sets. So we are going to change. I really believe that there will be a before and after on how science and engineering are going to be practiced in our nation.
You're extremely passionate about this subject. I've seen you speak about this at various events, and I'm an avid follower of you on LinkedIn and other platforms. I'm really excited, and I've met with the folks at NSF and NASA and the 26 that are out there. You know, there you can hear people talking about it, and there's a new sense of excitement. So that's really great. You know, today in 2022, we see Gen AI and the explosion of Open AI and other capabilities really, you know, come to fruition. We all get very excited about the momentum that brings. We're all, you know, asking lots of questions, getting lots of answers, and going forward. But really, you know, how do we see it move forward? Gen AI was the start, but how do we really gain mission advantage and really get the value? There's the enterprise adoption side of it, which can really change the game. But then there's the government side of it, which I'm extremely excited about, is, you know, how do we actually leverage these capabilities to, you know, truly gain mission advantage?
I would say two areas are the most present. One is we have to continue to press the capability such that it better aligns with mission. And the other one is we have to achieve scale and sort of a universal access so that everybody that needs to carry out those missions can do so effectively. On the first category, if I just speak at my world, on the world of science and engineering, the frontier is AI. We've done a good job with AI to get it to do language and coding well, right? I mean, of course, there's gaps, but it's very impressive of what we can do on that. We got to get AI now to do mathematics and physics and chemistry and material science and engineering of every type really well. And what that means is that we got to have the data sets, the domain expertise to train the next generation of AI such that it's able to do those things. So that is a frontier we have to be able to push. And then the second piece of it, imagining with that capability is there, then we got to achieve scale. Mm-hmm. And these have to go concurrent. And the scale means it really needs to be accessible, and the amount of, you know, inference compute that we got to make available to very large number of federal employees, of our partners or contractors in the national laboratories is very significant. And I don't think it's going to come as a surprise, but we don't have enough AI compute in the federal government and in the university ecosystem around that.
I've heard that.
Yeah, I heard, right? So we got to solve that problem together.
You know,
and it's both supply chain issues and things around that, but it's also an understanding of what are the capabilities and investments that are going to be required to do that. So those are the two things that I see, and at some point maybe we can chat the next frontier also on quantum.
Yes.
Yeah, I would add. I think this edge computing element is going to be incredibly important, particularly as we, go out into the field and we have real-time analytics, and we can't have everything go back to the center for the answer, right? You know, it's got to be engaged in the physical world where the activity is, and also, just from a cost of token standpoint, it's going to be way less expensive to do inference on device and not have the round tripping of all the data and all that, and for a lot of the use cases. I think all the work that we do around zero trust, that will be incredibly important, particularly as we have all these agents running around, right? We need a way to make sure we can trust them also.
That's right.
Because we could have cyber challenges at AI and quantum scale, so that would be a real problem. And then quantum readiness in terms of the defense side on post-quantum encryption, and how we prepare for this kind of combinatorial effect of quantum and AI together. You've been thinking a lot about that. And then finally, we just need a lot of energy for all this, right? Because the need for compute drives the need for energy, and economic activity is energy transformed, and so we need more energy.
Yeah.
And all of this ties together because economic security, national security are incredibly intertwined.
That's right.
Yeah, Dario, what are your thoughts on that, right? Especially as we think of, AI scaling, we think about sustainability, resilience. It's a big challenge, right, for government. We think about efficiency, and just I'd love to hear what your thoughts are on how we overcome this.
I mean, first, it's Mike and I were chatting before starting here. It's just amazing to just pause for a second and realize where we are, right, on compute. I mean, we're talking about megawatts, right, on racks. The scale of the systems we're building. I mean, as a nation, the biggest machines that we would build will be the famous supercomputers, right? And they would be, maybe 20, 50 megawatts or something like that. And it was like, wow.
Sounds kind of quaint now.
It's quaint, right? It's a national effort, and you would be like, amazing. And now people, and then, a few years ago, started hearing about we're going to build a gigawatt machine. And now people are talking 10 gigawatts. And you're like, well, how big is this going to get? So just to realize, and if you look on the grid, on electricity, if you plot electricity consumption and electricity production in the United States over the last 30 years, it's kind of flattish to slightly declining. And now, totally different story. Right, so this computing revolution, it is driving, and the appetite to reindustrialize the country and another, sets of uses, it is transforming the energy landscape, right? So Secretary Wright and the President have been very clear that we need a world of energy addition, not subtraction, right? We need more energy, and in fact, energy is becoming the rate limiting step. If you look at the majority of large-scale projects and the discussions we're having inside the government or where we need more AI compute, in the end, you end up saying, well, who has energy available, in what time frame, where can we locate it, and so on. So they go hand in hand. And that's why in the Department of Energy is so important of what are all the policies and actions we're taking to see a world of energy abundance and for the United States. And those are many different dimensions. The grid, how we're going to strengthen and grow and make it more resilient. It is also the renaissance of nuclear that we're seeing that is incredibly important. Within my portfolio, also in the next horizon, pushing towards fusion and realizing fusion energy and the first fusion power plants in the early 2030s. And so that's on that front. And then architecturally on computing, we also have to continue to innovate. And this is the classic challenge of, okay, as inference, the cost of compute, the power performance continues to improve, but people want more of it, right? So you end up consuming more energy. But nonetheless, we gotta continue to push on architectural innovations such that the cost to implement these neural networks and compute continues to dramatically go down. So those are the two factors. But energy and the story of AI and compute are two sides of the same coin.
Even though the efficiencies come, we don't necessarily give it back, right? We want more, to your point.
Yeah, well, that's been we've learned that story, right, on Moore's Law, right? Nominally, you could keep the same number of transistors and make it twice, but people wanted always the transistors.
Well, I think also what's fundamentally happening here is different than what we've experienced in the last 60 years, because in these 26 domains you're talking about, what's happening is we're creating intelligence. Right, and we never really did that before, right? We had calculations, we had computing. Now we have machines that are helping us think and thinking for us, and that is probably the biggest advance that humans will ever see, or at least so far, right? And so the trying to get your arms around what is the demand for intelligence. Nobody really knows, but it's certainly much higher than we have today.
No doubt. And Secretary Wright always speaks about energy is life, but in this thing is energy is intelligence too. They both go hand in hand, and I think the appetite for how much intelligence we want to have in our world, I don't think we're going to stop at any time, and frankly we need it. I mean, a lot of people have this sort of share the apocalyptic version, but I don't have that point of view, because we haven't run out of problems to solve in the world, right? I tell people, and frankly, we need all the help we can get, and if we can harness that power towards the purpose, and that's where the national challenges are important. What are we trying to solve? Inspiring people on the problem set and then utilizing this new intelligence at scale, it's such a fun time to go and you say, well, let's go tackle those things. Making fusion happen, it's hard, right? It's a really hard problem to build a star on Earth, right? But let's go do it. And don't you worry that there'll be plenty of talent that is needed and people to make that happen.
That's the optimism. Let's go do it, right? I love that. So thank you for saying that. Michael, you've said to me several times and to our customers, AI, is amazing, but the infrastructure is the backbone. You spoke about data earlier. We can give a lot of tools to a lot of people, but it's really about what do you do with it? How do you bring it to scale? How do you make it operational, if you will? So I'd love your thoughts around that and how we actually take this and make it real is the way I think of it.
Yeah, I think what we don't want to do is start with the technology. I think we want to start with the mission outcomes and the purpose of what it is we're doing and why we're doing it, and working with the agencies to design, mission-ready technology. Obviously there are new requirements here, and having a system that is scalable and secure and also works in all variety of domains, whether it's on-prem, cloud, edge, classified environments, and delivering that with again an open architecture and observability and the right controls is incredibly important. And it only works if it's where the mission occurs. So that could be in space, that could be out in the field, and everywhere else. So that's how we need to think about the infrastructure from the mission back.
Yeah. I keep talking about space being the real edge, right? As we go further out, we've got to figure out
the far edge.
Yeah, the far edge, right? Exactly. Building on that, where do you think agencies and enterprises, where do you think we're seeing the fastest growth leveraging AI?
Yeah, I would say, when I look at enterprise and commercial, I would say maybe only 10 or 15% of companies have sort of figured out that this is an enormous fulcrum for reinventing and reimagining their companies. But I think more and more of them are getting there. In government, there are obvious use cases that we're starting to see, again, move from pilot to production in modernizing and automating, high volume workflows, collapsing the cycle time to deal with enormous amounts of data, and rework all the things that touch millions of citizens and make those way more effective. And I think the citizens are expecting that, right? They're expecting it to work the way it kind of works in the commercial world. Clearly, the AI assistance for IT and developer productivity, that is a rampant use case everywhere. Everybody's figured out that is a fantastic way to boost productivity and efficiency and speed of resolution and progress. And then there's the need to modernize infrastructure and do it in a way that delivers cost and productivity gains. Those are a lot of the lessons that we have from the commercial world. And one of the sort of things that we've highlighted is and Dario knows this, is very focused on it, kind of the gap between what's going on in the commercial world and the public sector. It's gotten pretty large, and so it can't be that big of a gap, right? And so we want to help drive that progress faster, and we've got a lot of the building blocks and learnings and sort of pre-built solutions that are proven and tested that we know how to apply.
Yeah. That's why I'm really excited about Genesis, because it really pushes the envelope and builds that cycle that you were talking about earlier, and helps us, speed up the innovation that needs to happen across government. Dario, I've heard you speak. I saw a post from you on LinkedIn, maybe yesterday, day before, around bringing the brightest minds together from university, academia to talk about AI and the capabilities that are that can be achieved. You kind of highlighted supercomputing and AI is really the next level, and then behind that is quantum. Really would like to get your thoughts around STEM, the workforce, the long view, right? And I was at an event with you, and there was a student in the audience, and he asked you a question, and it was all around how he can participate and get in the mission. And I really enjoyed the fact that he was so excited to jump in, and he was still at university and hadn't come out. How do we get this, to become pervasive, and that we get, education really going so that we can get the next generation moving in this direction?
This is a topic that is very, close to my heart, and I care a lot about it because, in the end, that is the most enduring transformation and agent of change that we could have, which is inspiring the next generation of scientists and engineers to go and tackle, the most ambitious problems that we want to solve as a society. So I think one big opportunity and the reason why we also named the initiative, we wanted to have an inspiration to the whole country, and in very particular, also to the next generation of scientists and engineers to look up and you say, I want to be part of that. I can help that successful. And that's when we do the historical parallels of, well, this is like a modern day Apollo program or so on, that's the parallels. Obviously, one has to earn it, right? It has to earn and deliver that impact to be considered sort of in that league. But it's helpful to begin with that inspiration and that aspiration around that. So we have signaled very broadly that this is a national effort, that everybody that wants to participate, we got to find a way to help them participate. And very specifically, we've been engaging with universities. So the month of February was the month, what I call of like listening and engaging with the university ecosystem. And what that means is everything from holding salon dinners and events with university presidents that I've been doing. We had a very large event in mid-February, which is linked to that post that you mentioned on LinkedIn, where we invited 500 participants representing universities from all across America, both public and private, all the different regions. And we gave them tasks to say, okay, how can you help us make the Genesis mission a success? Yeah. And we broke into working groups that involve everything from how should we partner differently? What infrastructure do universities need? How should the curriculum evolve and the degrees evolve in the age of AI, and what should we do about that? And it was very interesting and revealing feedback from that process. We also put an RFI out that just closed last week, and I think it's been the record response we've ever had in the Office of Science, where we were asking, we set some goals. It's like, what would it take for us to train 100,000 Americans with sort of this dual capability of being a physicist and using AI and engineer and doing AI and so on. And so we are now absorbing all of that feedback and formulating a strategy of how we're going to engage with universities. And for example, ranges of feedback we've gotten include how should the curriculums evolve and the degrees evolve. Examples, there's been quite a few universities that have been creating these colleges of computing, and now you study your degree and you end up with dual degrees, right, of your domain, right, that you're going to be an electrical engineer plus computing or plus, AI. And so that evolution, I think actually, I really believe that the students are going to be teaching the professors on this topic, because they're already growing up in a way that they're just thinking about it differently. And so that's very exciting. So degree evolution, very popular recently has been these 4+1 degrees, where you study your bachelor's plus a master's, hugely popular in many areas. So we were saying, okay, we've seen sort of like partial erosion of Americans' participation in PhD programs in science and engineering. What would it take us to change that? And there was, as part of this dialogue, the president of Purdue already shared a first pilot of, he calls it B2D in 7 years, right? So from bachelor's to doctorate in 7 years. So how do we accelerate also the time to PhD on this? What is the evolution of our fellowship program? Such that when we support our fellowship programs, they have internship opportunities, for example, in the national laboratories, but in private sector with industry, and allow a more fluid interaction and capabilities around that. So this is an area where we gotta continue to be very creative and experiment. And I think one of the things we want to do in Genesis is allow the space to experiment with new things to accelerate change, right? And I think the universities are welcoming that because they need a little bit of that forcing function of say, let's try new things.
Yeah, it's giving them mojo back, right? Because now it's driving new capability and their relevance changes. I love this idea of bachelor's to doctorate in 7. That's amazing, and those types of things are going to keep people going and moving forward. From our perspective, we've been working quite a bit with OPM around the U.S. Tech Force Initiative and the upskilling of federal employees to leverage new capabilities. And Dell is a partner in that endeavor. And it's all of us, everyone in this room. We've got to upskill our capabilities, and we want that generation to be even smarter as they're coming in and taking over, if you will. So I'm very excited about that. Go further, right? Now we've got quantum. And, I know you're very passionate about quantum.
I am.
I would love to hear your thoughts on quantum and where that takes it beyond AI and today's technology into the future.
Well, quantum is that third leg of the stool. Yeah. And it's so exciting. I mean, this is a field that got started, the field of quantum information science in the early 1970s, around that. So it's been going on for quite a while. And it's nothing less than revisiting the fundamental building block of the nature of information. And it turns out that the bit is not that building block. Believe it or not, there's something even more fundamental, which is the quantum bit. And so we've known the theoretical underpinnings that we could express information more richly, exploiting insights from quantum mechanics, namely that we can use entanglement as a means to represent that information with a number of states and a power that we cannot achieve through classical machines. So that's been known for a long time. The difference right now is we have the technology to realize this at a meaningful scale. So quantum computers have been around for a little while, right? They were very modest in size. I remember being at the time in the team that put the first quantum computer on the cloud. That was 2016. So they're very modest, but it allowed you to start doing the hello world example and the equivalent of programming in assembly, right? And just running those. But they progressed a lot, and we are on the cusp, meaning in the next 2 years, I believe that we will see the first error-corrected quantum computers. So we have set this goal of we need to mobilize the capacity of the whole country, the private sector, and the entire ecosystem to realize the first generation of scientifically relevant quantum computers. That says there needs to be something perhaps on the order of a couple hundred qubits with 100 million operations on that order. So it's really exciting. I mean, it's been decades in the making, and the fact that we're on the cusp of enabling these things is extraordinary. And that then needs to accompany the use of those instruments, just like we're doing with AI, for things that have economic relevance and scientific relevance. So super fun time in the world of quantum. And I think the whole ecosystem is really energized by it. Michael also mentioned the implications that this will also have for the migration that we got to accelerate also for quantum safe cryptography and post-quantum encryption. So there's consequences to this that are really high stake, but I really believe that we are going to see this next generation of quantum computers in the next couple of years. And this is what's amazing in general, that we used to talk about these things, everything is like 10 years out or 15. Now everything in any area of technology is like the horizon keeps getting closer and closer. So just I tell people, you ain't seen nothing yet. Just wait what's going to happen in the next 2 to 3 years, both on AI and in quantum. It's going to be quite spectacular.
And Darío, could you share your thoughts briefly on sort of, we have the CPU innovation, the GPU innovation, and now quantum. How do those all work together?
Yeah, that's a great point. I mean, in the future, like the systems and our data center environments will be built with combinations of CPUs, GPUs, and QPUs, right? I mean, and just like we've gotten accustomed nowadays that we always see CPUs and GPUs going in concert, we're going to add a third element to the equation.
I think that's just an important point because people hear quantum and they think, okay,
it's this other thing over here, right?
No, it's actually an additional thing that's part of the thing.
That's exactly right. that is exactly right. And look, quantum computers don't work by themselves. They need classical computers to work in concert with it. So I think the future will be, we'll have those modalities present as a plus, integrated into an environment. And then there'll be a programming layer on top. And as we know, the programming layers have been abstracted so much so that now it looks like language, right? So you have it there. And then the algorithms and the libraries will determine what's most efficient to run where. Just like we say, if you want to do matrix multiplication, you want to use it in the GPU, but if you want to, do algebra, it's most efficient to do it in the CPU. So there is this thing, and the same thing will happen with quantum. There'll be certain algorithmic primitives implemented in libraries that will run natively in the QPU. And when we do this well together, the user will know, it'll be transparent to them. It's just behind the scene, things are running where they should.
Exactly, yeah.
So exciting. Before we wrap up, Dell, NVIDIA, Department of Energy have been working with NERSC on implementing the new Doudna cluster. Would like to hear from both of you kind of on where you see that going, the progress that's been made, and just would really just like to open it up to you. We're really proud of it. I was in the team that was going after it, and there's a number of us in the room. We were very excited to work with Department of Energy on this, and would really like to hear your thoughts on it.
Yeah, well, I think this is a super important effort, and I would say co-engineering, across the Department of Energy and Dell Technologies, and I think it will serve as a blueprint for federal AI and HPC systems, and it kind of leverages a lot of our strengths around open, high-performance, scalable infrastructure, and all the work that we've been doing in the commercial world or in integrated rack-scalable systems with all the things that we build, and obviously in deep partnership with NVIDIA, and all this is going to create kind of this scalable compute for advancing American leadership in science and engineering and accelerating scientific discovery. So all that's incredibly important, and I think applicable across not just the national labs, but also defense and health and intelligence and manufacturing and everything else. So incredibly excited, and again, our teams are super passionate about making the project an incredible success and a blueprint for others.
I'm excited that it's a scientific cluster. The number of scientists that are going to be jumping into the system are just enabling
it's sort of
the
fuel
next
for your 26 challenges and.
Exactly. Look, I mean, and that facility is so important, right? The NERSC facility, so we operate these user facilities as part of the Office of Science that supports tens of thousands of the best scientists across America. That environment alone, supported 7 Nobel Prize winners, right? The NERSC, just to give you a sense of it. And on an annual basis, NERSC supports 11,000 of our scientists across the country. So this capability that we're building together is going to be transformative, right? Yeah. Because the amount of, both for simulation codes, but for sort of AI native workloads, it's a game changer. Yeah. And so we're very excited that the early access program and the first prototypes have already been stood up. This facility is going to be operational in mid-2027. So yeah, I'm just delighted about the partnership for this particular facility. I'm also very excited that Dell was part of our Genesis Mission Consortium, right? That we have stood up, that we have partnerships around that, because this is an exemplar of an amazing capability, but we gotta continue to be building, and adding more and more capabilities. But
keep going.
It's gonna make a huge difference. The Doubtness system. Yeah.
Fantastic. Well, thank you both for being here. I'm extremely humbled that you took the time to spend and on stage with me, and I really appreciate it. Thank you both very much.
Thank you.
Let me give you this, and thank you very much.
Thank you, Dario. That's great.
I think you're exiting this way. Thank you again. Appreciate it. All right. Thanks. All right. Stager is, we're good? Yes. Okay. I don't even know what that means. Somebody explain it to me later. We'll figure it out. I want to thank our partners. These events don't happen without the sponsorships. And really want to thank our diamond sponsor, Carahsoft, our silver sponsors, Intel, Microsoft, and NVIDIA. You'll hear from them in the breakout sessions. Please make sure you attend. Look, what we've discussed today, and I really am truly humbled that they took the time to be here with me. I spend a lot of time following them and learning from them online and virtually. So it's exciting to hear from them right here in the room. What we're building is mission-ready architecture, right? We are engaged in a lot of different capabilities that are aligned to government outcomes, to government mission. When you think about how this works, right, going forward is really about our partnerships and collaborations. There's one thing to respond to an RFP, but there's another part where we have to think about what are we actually doing and what is the outcome that we're trying to drive for, as Dario said. So there's a meaningful sort of thing that we have to think about as we're engaging in these opportunities and working with government. It's got to look a little different. Ultimately, the federal workforce, as we think about who gets it done and how we make that happen, it's the scientists, it's federal healthcare, it's our federal workforce that's actually executing on a day-to-day, it's our military. Ultimately, we are building systems that are going to be used to enable the federal workforce, and we really have to stand behind that. So, look, I'm very thankful that I get to support this community and my team gets to support this community. Ultimately, we're doing really big things as a group. Whether you're in government today or you're on the community side supporting government, we have a big mission and a task ahead, and please keep that in your mind. As you are here, please take a moment to attend all the breakouts. I think they're going to be, there's a number of breakouts happening. Later on, there will be a slide that shows you the actual breakout sessions. And thank you for being here. Thank you for taking time to attend the Federal Symposium. We're back and looking forward to continuing this. I will see you later today as we're moving around, but thank you all for being here.